All right, for the academic program, I've tied this together with the Pythagorean theorem. We're going to do some similar triangle proofs. And what we want, the goal today is I know what makes two triangles similar. So that's the first thing. I want you to be able to tell me that on a test situation. And secondly, can you follow the proof format to show that they're similar? So proofs are something that isn't quite emphasized as much as it used to be in the good old days, back when I walked uphill both ways to school. However, we still need to have some of that knowledge and structure put in place. So we're going to do similar triangle proofs, and there are going to be some people that don't probably enjoy them as much, but you realize it's not as difficult as it seems. So proving similar triangles. Before you can use the fact that two triangles are similar, you have to give reason that they're being similar. So we've already done the similar triangle calculations. So on tests and exam, I'm going to tell you that these are similar. You don't have to do the proof, and then there'll be a separate section or separate question that says, explain to me why they are similar. Okay? So there are two ways to tell. Okay? If the sides have the same ratio, okay, so that's one way. And the other one is if they have all the same angles. Okay, so we're going to go over the process so that you have the structure. This is what we expect grade 9, 10, 11, 12 in terms of a proof. And you'll see that it's not nearly as bad as you think. All right, so for question number 1. The following triangles show that triangle QRS is similar to TUS. Okay, so what we do is we create a T-chart. All right, and the T-chart looks like this. We have a statement in the first column, and then we have a reason in the second column. All right, so in order for two triangles to be similar, we either have to show that the ratios are the same, so we're given no length, so we're not going to be doing that. So we're going to have to prove that the three angles are the same. Okay, so here's how I would do it. The first thing we know is that these two angles are going to be equal. So that means that QSR, so angle QSR, and off to the side, I'll just put a note here, angle QSR, that's the angle in question. All right, so we use the three corners of the triangle, and we put the angle that we're interested in the middle. So angle QSR is equal to, so QSR is going to equal angle TSU. And how do I know that? What's my reasoning? Well, you can either do OAT for opposite angle theorem, or I'm quite happy if you can tell me it's the X pattern. Okay? As long as you can provide some evidence to me as to why that's true. Okay? So we have the X pattern. There we are. So that's one angle. Now, angle SQR. So angle SQR is equal to, well, I know that this angle, SQR, is going to be equal to angle STU. How do I know that? Again, if you're answering these questions, I can't hear you, so I mean, you can talk out loud. I do that all the time. But what happens is we have parallel lines, all right, and this creates what we call the Z pattern, right? The armpits of the Z smell the same, so those two angles are the same. So I'm just going to simply put the Z pattern. Finally, like my last set of angles here, change to the third color. I know that these two angles are going to be the same. And it's the same reasons that we had above, okay, or the previous one. So I know that QRS, angle QRS is equal to TUS because of the Z pattern. Because the three angles are the same, therefore triangle SQR is similar to triangle STU because angle, so the three A's, angle, theorem. And it's proven above. Okay, so this is your proof statement. You don't do this in your notes, okay? So this is your reasoning or proof. Reasoning slash proof. All right, and your goal is to get it down to angle, angle, angle. Okay, that's the format. That's what I'm expecting. That's what I want to see. Okay. Moving on to the second example. Surveyor lays out two triangles as shown, and he wants to find the width of the river W. Okay. Show that the two triangles are similar. So that's the goal here, and then use similar triangles to find the width. My focus, I'm not going to go through and do part B because you've already been practicing this. I just want to show or prove that they are similar. Okay. So, same thing, statement, reason. Statement and reason. All right. So if we're looking at it, we know we have right angles here. And that's given information. Okay, and you can write it that way. So angle CDE is equal to angle CBA. And you just say given. It's in the diagram. I don't have to prove that. What else am I given here? I know that at point C, these two angles are going to be equal. So I know that angle DCE is equal to BCA. And that's, again, the Oat theorem or X pattern. So I have those as being equal. And then if those two are true, then we know that the other one, even though it doesn't tell us AB and DE are not parallel, so we can't really say that, but we can then say BAC, so angle BAC, so this is the last angle here, and angle BEC are equal. And the reasoning for that, because we're not told it's parallel, we can cheat a little bit and say, well, it's not cheating. We're going to look at it a little bit different, I should say. We know the first two sets of angles are equal. So those last two have to be equal because of the sum of angles in a triangle. They add up to 180. So if you take the same, first two angles are all equal. If you take the same amount away, the third one has to be the same by definition. So therefore, triangle, let's go DCE, is similar to triangle, so DCE, so triangle BCA. So those two triangles are similar. Okay, and again, same as we did above, because so we're given a reason. There's different theorems out there, so I just want you to get into the habit because of the angle theorem. I'm just going to add that in down here. A, angle, three angles equal. All right. And then B part, you've done enough. You don't need to see me do another similar triangle question. So we've done the proof for that. And finally, our third and final example here, determine whether the following triangles are similar. So now I have no angles, okay? I have what I think are, I can kind of approximately match them up. And that's what I'm going to do. I'm going to go, okay, by appearance, it looks like AB matches up with, and I would say DF. So I'm making that assumption, just going by I here. Okay, I'm just looking at that. The longest side AC matches with the longest side EF. And finally, BC is going to match up with DE. Okay, so I'm just going to put this, required to prove. So it's not true until we prove it. Okay, so the first thing I'm going to do then, I'm going to go down and I'm going to say, what does AB over DF equal? Well, AB is 14, DF is 8, so that gives me approximately, and I'm going to reduce it because I want to keep it as exact value. So they both divide into 2, so I get 7/4. So I'm going to leave it like that for the moment. Moving across, I'm going to look at AC. and EF. So AC is 36, EF is 20. So I want to reduce that fraction. So top and bottom, they'll divide by 4. So we end up with 9/5, and BC over DE is equal to, so BC is 18, DE is 10. So when I reduce this one, I end up with 9/5. So it's close, but close only counts in horseshoes and various other games like that. But because the first fraction is in fact not equal, so we put a slash to that, AC over EF, and BC, the last sets of fractions, were equal. So therefore, the triangles are not similar. There we are. Okay, so the triangles are not similar. And that's it. We've proven that because the fractions, the constant is not the same all the way through. All right, so we'll leave it there. Homework's on the website. That's what we're going to be working on in class tomorrow. If you have any questions, you want the process clarified, please make sure you do ask.